The last meeting we talked about probability, and we did some introduction about probability, and then you so far I hope you understand the basic concept of probability already. Okay, so today we are going to learn a new topic, what I call it, counting techniques. So why do we learn counting techniques? So the key concept here is that, so in many probability problems, yeah, so when you calculate a probability specifically for the classical problem of classical method of calculating probability, so the big obstacle is finding the total number of outcomes, or what you call a sample space, right? Or what are all the possible outcomes of a certain procedure? That probably is one of the biggest problem in calculating probability, right? So in this part of the class, I am going to teach you a technique in which you can use to calculate all the possible outcomes when calculating for a probability. Okay? So, comprende to? Itong kanig di hana sana eh. Semana ko to kita aprende con ba probabilidade los gala eh. So, ia probabilidade me aprende con ba probabilidade nenen. Buat nebe susar liu neme imi ato haten in sample space kata all the possible outcomes, ya. Posibilidades so hotu nebe ato se acontece ba ihe tania experiment ida ga procedure eda ne maka ito susar ita ato hetang los galan. Semana ko to liu hawa noring imi ona be soida the three diagram los galay. For example, ane sambe ba restaurant ne imi belu uje three diagram. That's one way. But this time, I am going to teach you a more mathematical way of looking at of finding all the possible outcomes. Alrighty. So let's start with just giving an example. All right, Favanyo, read this for us.
Let's imagine Celeste is in a desperate need of money. Therefore, she went out and bought a SDSB to try her luck. She aimed at winning. She aimed at winning.
Bola mera. Just say bola mera.
Bola mera.
Which
is $2,000 if you win $1 with 4 number combinations. What is the probability that Celeste will win Bola Mera? Do I continue?
All right, that's it. Thank you. So basically, por ejemplo, Celeste viene precisa los osang. Y después, ni precisa los osang ni akarak, por ejemplo, akarak bajo la ticket iba pasir e Bali, por exemplo. Basta? Então, dia habas kokoto kani sorti SDSB kita halau kona bola merah kari. Au hetan $2,000. Biasa SDSB ne kan ososa $1 kali 1 iha nomor hat ne maka kona berarti hetan $2,000. Los kali, saya pernah 5 SDSB.
Los, teacher.
Okay. Ida ne los. Agora, então probabilidade saída maka Celeste ne se bele manam bola merah. What is the probability? Okay, in order agora o isa may tato calcula probabilidade o isa sira sa probabilidade sa mas Celeste se manang. Agora, like I said before, in order to calculate the probability of this, we need to know how many possible 4 number combinations are there. Dale? Ato calcula, por exemplo, Celeste ne sosa será, por exemplo. Nomor nebe Celeste sosa na será. Let's say I write 3,052. This Celeste number, yeah? For example, this is Celeste's number. Okay? Now, probabilidade saída, maka, número na nene, se acontece, imiharia la wakerek neto?
Yes, sir.
Okay, probabilidade saída, maka ne. So, agora, número nene, número ne bele barbar, ni bele sai 0001, o da rumania 000, outro ritmos bele, o 0102, or 0313, ola tiene lo salai. four number combination atau side ini possibilidade iya hotu los kale. Ne los kale. Los
Lost
kale.
teacher.
So possibilidade combinação número hard ne bele iya possibilidade atau sai hotu iya bola merah. Agora perguntas ne mane, então total be possibilidade ne gira. Total all the possible outcomes ne saída. Então kita tem que usar uluk, kita tem que buka uluk kita ne. Ok, ne be kita calcular nessa ne. Por exemplo, a hora tem número hard lo sala. Ene kan número primeiro, por exemplo, total tem lai. Total talai be. This is the first number. This is the second number. This is the third number. This is the fourth number. Okay. So let's make this as a first number, first digit. Digit to primeiro, you have a número hard ne. Second digit. Third digit. Fourth digit. Okay. Now, digit to primeiro ne número sério mas bela sai. Nia bele 0, bele 1, bele 2, bele 3, bele 4, to bele 9, lo zalai? Berarti there is 10 possible number. Like nia bele 0, bele 1, bele 2, bele 3, lo zalai? Every digit has to be, it can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, lo zalai? 9, to 9, lo zalai? Yan bane shirane bel sayo to ne be so sura kare ene ka 1 so yeah, so if you count it, this is 2 3 4 5 6 7 8 9 10 nebe total posibilidade nebe ya first digit ne bele kosong bele 1 bele mos 2 bele mos 5 bele menos ola tene da mas ben nia ya posibilidade ne ya sanulu mak bele ya ne losto comprende na sanulu ne comprende ale.
Yes, sir.
Yes, teacher.
The second digit ne mas hanesang. Niya mas beles 0, beles 1, beles 2, beles 3, beles 10 to. Correct?
Yes, teacher.
Okay. So that is also a possibility of 10. Third mas hanesang. Niya bele kosong, bele 6, bele 8, bele 3, bele 2, ola 10. Ini mas 10 to. 10 to. Nebe, se cada digit tu ida nene, niya iha 10 possibilities, antau ita tinggal vejas dan pemalo. Antau niya all the possible outcome will be 10,000 possible outcome, no sila? So 10,000 4-digit number combination. 10,000 4-digit combination, no sila? Kata total nene, posibilidad ini niya iha 10,000 kombinasi. Niya bele combina entre 5, 4, 3, 2, bele 5, por ejemplo, 5, 4, 3, 2, bele fali 5, 4, 3, 4, bele fali 5, 4, 4, 3. Ruane mas lanesang ida dala. Sila constituye el número nebe hanesa mebe la hanesa, nemos posibilidad de rua ida ne. Nebe hamutuk ne maka ni a total of 10,000 possibilities. So this is the total number of outcome. Okay, nebe, for example, if I say A is probability, por ejemplo, bola merah ya. Probability of, por ejemplo, bola merah. Probabilidade saída maka celeste ninya nomornya bola merah. Okay. Agora celeste kan só de números kali 1 deh. Itu salah kali 1 artinya nya nomor angka nih ya ida deh. 3 4 será combinação número dígito hard nih ya ida. Dari 10,000 possibilities. Masalah 10,000 nih masih ida nih. Idanya tambah celeste sosa kali 1 deh. Jadi the probability of this is very very low. So which is about 0.00 0.01 or approximately atau persentase yang correct 0,01% probability para Celeste at tumanam bola merah. Does this look like a this is not a very good odds. Los lá, né? Que quantos, né? Probabilidade né? Celeste semana né? Que quantos. Pero minha mãe Celeste tem que gastar nessa $1 que ela liga. Dekho ali que ela. Compreende que ela?
Yeah.
Yes,
Pergunta?
teacher.
Got it, sir.
Okay, so that's probability. So okay, so that's one counting technique, yeah. Ildefonsus, read this for us.
For a sequence of two events in which the first event can occur m ways and the second event can occur n ways, the events together can occur a total of m times n ways.
Correct. And as ang going to harito ni Diam. For an event, for a sequence of two events, event turua, in which the first event can occur in M. Por exemplo, o SDSB kan evento primeiro da first digit ne evento ida, second digit ne evento ida, lo salah. Nekan this is event 1. Event 1, this is event 2. Owing ito niya event 1 and niya occur in how many ways? 10 possible ways. 10 ways, lo salah. Ida be, let's call this an M. Ida fali evento 2 mo sanes, and that's also 10 ways. Let's call this an N. Nebe antao, o maybe o hindi kani evento hat, lo salah. Yan fali mo siya third. Let's call this event 3 to tirmalo, lo salah. Event 4. This is fourth digit, lo salah. So name was 10. Ida name was 10 ways so to. Let's call this MN P and Q, not Q, not P. Let's call this MN XY. XY. Nebe, atubuka be, the events together can occur in M.M, and nebe o tinggal calculate each individual ways together. So just simply M.N.X.Y. So just 10.10.10.10. So that's how you get a 10,000 way. That's the fundamental counting rule. Okay, nemo oing tahalatan, nemo oing mihareta na ihabe example da be. Example da nene, that's we apply fundamental counting rule, yeah? Nebe rule primero i matene tena, técnico da primero i matene tena. Ne fundamental counting rule nemo kane. Agora, sebelum ita ba fali be. Okay, por exemplo, tak ida neto, ida nekan i mihalo tena lo salam. You're taking your family to lunch at the restaurant. The menu are 3 types of chicken dishes. So you have chicken, also like chicken dishes, and then okay, chicken, vegetables, pork, and then beef. Those are like how many ways can you select chicken dish? You have 3 types of chicken dish. You have 4 types of vegetable dish, and then you have 2 types of pork dish, and then you have 3 types of beef dish. There are 4 M ways. So let's call this an M, let's call this an N, this is an X, and this is the Y. Whatever you call it doesn't matter. So if you want to calculate how many possible this combination, so total outcome, all possible outcome, total number of all possible outcome. Okay, so I should say, so the number of all possible outcome, yeah, possibilidade is just simply multiplying them together, right? So you just multiply 3.4, those 2, 3. So you will get 12, 24 plus times 3 is what? Wait, what? So 9 times 8. 3 times 4 is 12. 12 times 2 is 24. 24 times 3 is what? 12, 1, 72. Okay, so 72 possible ways. there are 72 ways in which you can select one dish from each section. This is, so event 1 is when you select the first chicken dish, second and then vegetable dish, and then pork dish. Comprende to? So this is fundamental counting technique. Preguntas sa rumah?
No, teacher.
Any questions? Okay. Yung silo ko isa. Comprende ito na?
Yes, sir.
All right, so good. So now let's go to a new topic. So this topic is we're talking about factorial. So factorial notation. Usually in mathematics, when you see a symbol like a symbol like this is a symbol for factorial. Okay, this is the factorial symbol. Denotes the product of this decreasing positive whole numbers. For example, sekarik hawa kerek 4 factorial hanesane, that simply means 4 times 3 times 2 times 1. 2 malu multiplica, which is equals to 24. 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is just 24. Okay. Maybe you have factorial special definition factorial ne 0 factorial ne laos 0 ya. It's just simply 1. If you ask me why and how, I don't know. Ne ema mathematician sira makalo definition ganin. I just use it like you guys. So there's a special topic, advanced mathematics, to answer the question as why 0 factorial is a 1. But for the sake of this class, let's just accept that this is true. Yeah, this is true, by the way. It's not true. I just don't know how to prove it yet because I haven't studied to that point. But this is true. Let's just accept that 0 factorial is equals to 1. Okay, this is a mathematical definition. Yeah. Okay, so factorial simply means that so if I write 5 factorial, that simply means what? 5 times 4 times 3 times 2 times 1, which is equals to 20, 60, 120. If I write 2 factorial, I simply means 2 times 1, which is simply 2. If I write 1 factorial, it's simply just 1. 1. Okay, comprende na sa mga factorial to?
Comprende, teacher.
Okay, so there's another one over here, factorial rule. Okay. Okay. Natalia Fernandez, can you read this for us?
Number of different permutations or order counts of n different items can be arranged when all n of them are selected. This factorial rule reflects the fact that the first item may be selected in different ways. The second item may be selected in n minus 1 ways and so on.
Okay, Nidian Sane, thank you. So Nidian Sane, number of different permutation or order of counts of n different items, you have n different items can be arranged when all n of them are selected. This factorial rule reflects the fact that the first item may be selected in n different ways. The second item will be selected in n minus 1 ways and so on. Na, por ejemplo, imi 40, imi a basket ida nilarang, wala imi iha laranja, wala imi iha apple, and then imi iha what else? Laranja ni masabrak kane apple, and then sa tama iPhone sa ayata, for example. Okay. So if I want to calculate probabilidade ida, for example, hawa karak 40 sai, take 2 fruits from the basket. Yeah, basket na may ida basira iPhone sila laran. Now, what is the probability of me picking an orange? Probabilidad na sayda. Huh? What is the probability of me picking an orange? Hello? Probabilidad how hili orange na sayda.
Um,
2
two,
over
I believe. Two.
Nine.
No, orange. How many orange has in the basket? This is our basket.
4.
Yes, 4.
4.
The
Oh, four. Yeah.
4 of 4 of
9.
9. So that's the probability of choosing an orange. Or approximately 0.44, yeah? 0.44. What about the probability of agora? Por exemplo, Bahira o select the orange idane, plus 11. So that means one of the orange is gone because you already take it out. And you already put it outside. You want to take fruit 1 over here. Agora calcula fali. What is the probability of getting a apple? For example, what is the probability of getting an apple?
3.
3 over
Over 8.
9.
8. Why 8?
Over 8.
Because one of the fruits is already taken out, so the total inside is now, instead of 9, it left with 8. That's what the definition is. So when you're talking about this, initially this n here is equals to 9. But here is n minus 1, meaning 9 minus 1, which is just equals to 8. Setiap kali, so that's what this factorial rule is. Tama na mo uja factorial ne, 4 factorial ne, ni tuntung. Ni tuntung. That's what the factorial rule based on upon. Okay? Ito na how Coco to explica ba imi tamasay na mahakerek ba. So, that's what it says. This factorial rule reflects the fact that the first item may be selected in n different ways. The second item may be selected in n minus 1 ways and so on. N minus 1, n minus 2, n minus 3, and so on. So, any comprende ito?
Yes.
Bella, teacher.
All right. All right. Let's do some examples over here. So, how do you calculate this rule? Okay, so how do you calculate this problem? Okay, let's do for letter A. So this is letter A is simple. So 3 factorial is simply 3 times 2 times 1, which is equals to 6. That's easy. What's the line? Okay, let's do a different color for B. Let's do for B. B is what? 5 minus 2 factorial. By here of factorial, you need to calculate first whatever is inside the parentheses. So 5 minus 2 is what? 5 minus 2. 5 minus 2 is
3.
3 factorial. So you can just simply write 3 factorial, which is equals to 6, the same as the one up there. Okay, let's just use different color for letter C. I like colorful. What about 5 factorial plus 2 factorial? Okay, 5 factorial is what? 5 times 4 times 3 times 2 times 1 plus 2 times 1, which is equal to, this is 5 times 4 is 20. 20 times 3 is what?
61. Teacher.
What? How do you get 61? 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is
120.
120 plus 2. So you will get
2.
122. So this factorial is that. Okay. Okay, what about letter D? So how do you get the factorial of 6 minus 2 factorial over 3 factorial and then 2 factorial. Okay, so 6 minus 2 is what? 4 factorial.
4.
And then this is 3 factorial, this is 2 factorial, right? But I can just simply write 4 times 3 factorial because this is the same thing as writing as 4 times 3 times 2 times 1. And then this region here is simply 3 factorial, right? So instead of writing everything down, I'm just writing this thing as simple as that. Okay, so let me just delete this. I'm just rewriting it like this. So divided by, and the reason I write like that so that I can easily cancel out. So I can cancel out the 3 factorial, so that's just 4 over 2 will just give me a 2 over here. Understand? Comprende to?
Comprende, teacher.
All
Comprende,
right.
teacher.
What about letter E? So that will be 5 factorial times 2 factorial. So 5 factorial is 5 times 4 times 3 times 2 times 1 multiply by 2 times 1, which is, this is 120 we know, and this is 2, so this will be equal to 240. Jadi logika salah. This is
Close.
wrong. Okay, ini salah. Okay, so ini halasan ini salah na. Okay, the correct way of doing it is this way. So 5 times here, you need to multiply first 5 times 2 first. And then factorial is just simply, so you just have to write 5 times 2 factorial like this. So you will get a 10 factorial. Like this. Comprende? So that will be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's 3,628,800. Okay. Kau tak punya kalkulator saya nasa negala.
Science teacher. Yes.
I don't know, maybe. Maybe I'm wrong. Dalam rumah salah. Okay, I think this is the correct one. The name loss, yeah. Sorry, I'm sorry. I apologize. This is the correct one. Let's make this instead of. Let's make this an F, a new problem. Okay, so there's a difference, yeah. Never. This is an E. This is an F. Ruannya loss to. Sekarang ni hakerek makanesane. Berarti imi tinggal imi halo kalkulasaune hanesane. Imi halo look be. Factorial ne mai hane, idane ne mai hane. Potete maka idane multiplica verne, you get 220. May be sekarang maka serenay ruannya may parenthesis niya larang hanesane. O labele halo kali hanesane. Ne salah. Okay? Sekarang hanesane berarti dan nabanet sai 10 factorial. Okay? Comprende kalian?
Comprende, teacher.
All right, so factorial is pretty easy, no? So that's a factorial. Okay, what about this one? Find the number of different ways that 5 test questions can be arranged in order. Find the number of different ways that 5 test questions can be arranged in different order. For example, ini have test ini perguntas 5. Let's call this question 1, question 2, question 3, and question 4, and then question 5. Masalah? Ini hakarak hala arrangement nene. Dalam rumah ia one arrangement 1. Ini bela hakarak tauluk imi tauluk question 1 primeiro, question 3 tia, depois question 4, question 5 tema, question 2. O dalam rumah minha carta fale question 5 ma pertama fale, question 4 ma pertama fale, question 2 fale, question 1 tema, question 3. How many possible arrangement? Imi bela halo arranjamento nessa nene dala hira maka how many total arrangement possible? Okay, this is for example, this is arrangement 1. We don't know. We can calculate that. So how do you calculate that? Arrangement 1 or arrangement 2? Okay, how many ways can you arrange this test? So you have 5 questions. So okay, number of ways, yeah. Bahira wa kerek be si nene. Bahira wa kerek bet kotakan sa nene da indicator number, yeah, number of ways. You just simply calculate 5 factorial. So 5 times 4 times 3 times 2 times 1, which is equals to 120 possible ways. Imi bela organiza question 5 nene, bababa maya na sa name. There are 120 possible ways to arrange this 5 test questions. Okay, so you can shuffle it. Nabe dalam rumah ia imininia be saida Google Classroom homework nene balu problema nebe ia balu halo ne ia nomor 1, balu halo fali ni ia falte nomor 10. Oh, ne how mas enggaja halo dunia sana. Comprende?
Pressure.
Okay, find the number of different ways the 3 players on a basketball team can line up for example, ia pemain tolo. Okay, so player 1, let's call this player 1, player 2, and let's call this player 3. For example, this is just one of Serna tolo na player 1 pertama, player 2. This is just one way of arranging them together, right? But you have all the different ways. So you can also arrange them. You put first player 2 first, and then you put player 3, and then you put player 1. That's another way. How many possible ways can you arrange them like this? So the number of ways is simply 3 factorial. So just simply 3 times 2 times 1. There's 6 possible ways. Okay, just because you only have 3 players. Comprende?
Comprende, sure.
Preguntas rumah ya nomor number 4 and number 5, example.
No.
Okay, Efrat,
None.
can you read this
Just two.
permutation rule for us?
Yes.
Go.
Permutations rule when items are all different. Requirements. 1. There are n different items available. This rule does not apply if some of the items are identical to others. Second, we select R of the n items without replacement. Third, we consider rearrangements of the sum of the same items to be different sequences. The permutation of ABC is different from CBA and is counted separately. If the preceding requirements are satisfied, the number of permutations or sequences or R items selected from n available items without replacement is n ER equals to n
Factorial. Yes.
over n minus
Ah.
r factorial.
Yes, thank you. Okay, that's a factorial symbol. So, I just want to make an explanation of this. Okay, what it says is that Ni requerimiento para permutation rule nene. Ini pernah Ronald ya form permutasan wala permutation. Have you heard of it? Ini pernah Ronald na permutation galas daw. Maybe you don't. There are n items available. You have n items available. This rule does not apply if some of the items are identical to each other. Sekali items ni identical niya la aplicaran. Without replacement, okay? And then one key here, permutasan na the permutation is ABC is different from CBA. Meskipun cada elemento ne forma husi hanesang A, hane amos iya, hanemos A iha, hanemos B iha, hanemos B iha, hanemos C iha, hanemos C iha. May be ya permutasan nene ita considera sanaruane la hanesang, ita conta rua. May permutasan or sila ita bafal combinação Chanarone iterate hanesande. So there is a difference. So that's what permutation is. Okay, so the formula for permutation is N, P, and R. R is simply the items that you selected from N available. For example, if you have 10 available and you select 2, therefore your R is 2, your N is 10. I'll give you an example in a minute. Okay, so that's what the if the procedure requirements are satisfied, the number of permutation or items selected for n available without replacement is, this is the formula. All right, remember this formula. You can write it down in your book. Okay, so this is the formula for permutation. Now, there's also a rule. You call it a permutation rule. So the permutation rule simply stated that there are n items available, okay, and the requirements for and some items are identical to others, okay. We select all of the n items without replacement. This is important, without replacement, yeah, no replacement. We consider arrangement of distinct items to be different sequences. Now, if the preceding requirements are satisfied, and if there are n alike, n1 alike, n2 alike, up to nk alike, the number of permutation or sequences of all items selected without replacement is this formula. So you have two formulas now. Formula ida mane. This is one formula. And another formula is this one. This is another formula. Okay? Remember that formula. Okay, ne permutasan ya permutation ya rua. Formula da oing hotang formula da ne. Or sila ita aplica ne depende ba problema no condição, ya. Agora, hotu terne ita ba fali ya combinations rule. Okay? Ita ba fali ya combinations rule. Okay, Paulo Sarmiento, can you read this combination rules for us?
Okay. Combination rule requirements. 1. There are n different items available. 2. We select R of the n items without replacement. 3. We consider rearrangement of the same items to be the same. The combination of ABC is the same as CBA. If the preceding requirements are satisfied, the number of combination of R items selected from n different items is NCR equals n over n
factorial
minus R.
No, you don't mean
factorial.
Okay.
R.
Repete, n factorial.
N factorial over n minus R factorial.
N minus R factorial and R factorial, okay? So this is the formula for combinations, combinations rules. So you have permutation rule, combination rule. So in permutation, you have two formulas. In the permutation rule, you have one formula. In the formula here, the only difference is that in combination, we consider A, B, C, nene, hanesamos o CBA, like I mentioned earlier. Why do we consider that? Because we know that here ito iha A, ihanemos iha A, ihane ito iha B, ihanemos iha B, ihane ito iha C, ihanemos iha C. Siya naroon na composto siya elemento ni B, hanesan Nebe trata siya naroon na hanesan In combination rule, ABC is equals to CBA. In combination, but in permutation is not. In permutation, ABC is not equal to CBA. In permutation. Okay, that's one big differences. Okay, so that's so now you have three formulas. Okay, Sidalia Suarez Viana, can you read this permutation versus combination for us?
Yes, sir. Permutations versus combinations. When different orderings of the same items are to be counted separately, we have a permutation problem. But when different orderings are not to be counted separately, we have a combination problem.
Okay, thank you. So, if when different orders of the same items are to be counted separately, kata permutation, kata ABC ho, ABC ane counted lanes na. We have a permutation problem. But when different orderings are not to be counted separately, we have a combination and permutation problem. So this is very important for you to distinguish between the two. Or the first thing you need to do is this a permutation problem or is this a combination problem? So, but in permutation, you have two formula. Ya formula ida pertama ne mga kape. Ato ne sa maybe ida nene ba hira o ya repetição. Ito uso ida ne ba hira o ya repetition ya. Ya oops. Ne permutation ne formula ida mane. Formula ida nene ito usa ba hira imi iha repetição. Okay, ida nene. Okay, let's do some example. I can okay, let's work on this example. In how many ways can you arrange two letters from the word love? Love na ito yung letter hira. L-E, O,
OVE.
and V-E. So you have 4 letters, okay? So that means you have the total of N is equals to 4. And you want to arrange 2 letters from the word love. You want to arrange 2 letters. So you can take L-O-V-E, O-L-E-V is not the same. So is this a permutation problem or is this a combination problem?
Combination.
No, this is a permutation problem because in this case, OV is not the same as VO. We count that as 1. So we call it because we just want to arrange them in 2. So our R here is simply 2.
2.
Okay, so how many possible arrangements can you do? Okay,
2.
so you can just write P and R is equal to N factorial over N minus R factorial. This is the permutation formula, correct? So all you need to write is you just simply write it down. So just simply write it down. P of N is 4, R is 2, which is equal to your N 4 factorial over 4 minus 2 factorial, which is just simply 4 factorial over 2 factorial, which is simply equal to 4 times 3 times 2 factorial, 2 factorial, and I'm just going to cancel this out. I left with equals to what? 12. So there are 12 possible ways in which you can arrange the word 2 letters from the word love. Okay. What about this? How many ways can we award the first, the second, and the third place prize among 8 contestants? Okay, first place is gold. And then silver is the second. And bronze is the third. Okay, for example, ito ya contestant sa nulo, 10 contestant. Let's say contestant 1. We call it C1, C2, until C10. So you have 10 different contestants. Understand? Dalam rumah ya kompetisaung ida nene contestant 1 mahetan first place. Maybe contestant 10 is getting the second place. Maybe contestant number 7 is getting on the third place. We don't know. Or maybe there is a contestant 8 is in the first place, contestant 9 is in the second place, and then contestant 2 is in the third place. We don't know that, right? But this is all possibilities. Okay, this is all possibilities. So how many different price or how many different ways can you do that? Now, before we calculate that, I need to ask, what is our N here? What is our N here?
8.
Yes. What is our R?
3.
3.
Because you want to take, you have N different ways and you want to take 3 different arrangements from the 8 people. 3 means first, second, and third. So this is a permutation. Is this a permutation? Because agora, por exemplo, C1, C10, C7. So let's say contestant 1, contestant 10, and contestant 7. Okay, this is the first place. This is the second place. And then this is the third place. Agora, se cada hala fali hanema ka contestant 7 fali, contestant 1, contestant 10, sila na or arrangement ruane meskipun hanesa net mabel event ruane lanesa los gala. Ihane contestant 7 ma juara 1 fali. Ihane contestant 1 ma juara 1 fali meskipun sila na composto si elemento nebe hanesa. Mabe event ruane lanesa ngida. Last though? So that is why we consider this as a permutation and not a combination. Comprende?
Yes, teacher.
Okay. So now you simply have to apply the permutation formula. P is equals to 8 and 3. So you simply 8 factorial over 8 minus 3 factorial. And then you have 8 factorial over 5 factorial, or you simply 8 times 7 times 6 times 5 factorial over 5 factorial. And you just simply cancels out the 5 factorial. And then you get that. So how many ways do you get? So 8 times 7 times 6. You have 336 ways. You can arrange award first, second, and third prize to 10 different 8 different contestants. Any questions? Preguntas, Ruma? Comprende?
Teacher,
Yes,
if I
sir.
could ask real quick.
Yes.
I was wondering about how did we come up with 10 of the contestants?
Oh yeah, it's supposed to be 8, yeah, not 10. Sorry.
Yeah, because it says 8, but
Yeah, it has to be 8. Yeah, it's not 10. Yes, you're right.
Yeah.
Thank you. So 8, yeah, contestant 1 to 8. All right, so we'll just have to replace this differently from 10. This is not 10, yeah. There's no 9 either. So let me just put the 6 here. And then 4. Wow. All right. Any other questions? All right. What about this problem? Do you think you guys can work on this? Is this an easy problem? For example, nessa daí, ini apa? Iminia be apa ho iminia amani armari ni imia tu husosa me be ser la fo me be imia cara ba sosa concert ticket los me be mini osan la mau tidak me thank you para nau be apa amani osan. Saya nunca. Saya pernah nau apa amani osan.
La pernah teacher.
Allah fiera. Balu pasti pernah.
Aze, Aze.
Oke.
Sempre.
Imagina imia cara foti atau ba sosa ticket ba concert, por exemplo, be, sabe? Taylor Swift ba concert di Timor. Imia cara ba sosa ticket ba nonton me be osan ras kali me be imia cara kan tu ba mau tidak mau opsi lah nau kon apa amani osan. Tiket $200 mo sosa na. Mau tidak mau nau kona. Me be apa ne amani ni be. Osane sabe o cadeado ida ba. Agora tu lo que armário né, eu tenho que ir a combinação número hard né, exatamente o foi me loque. Se o sala ida date, ola bele loque era. So how many ways can the então possibilidade né ia hira? How many agora os fali né permutation ka combination. Por exemplo, né 4, 5, 6, 9 o 9, 6, 5, 4 né, rua né hanesang. Ida né ita konta hanesang hanesang dit ka hanesang. Ini 4 iya, nemos 4 iya.
No.
5 iya, 5 iya. 6 iya, 6 iya. 9 iya. Ruanen composto elemento nebe hanes maybe scenario ne la hanes ida. The conta separata. So this is a permutation or a combination problem. Huh?
Fermentation.
This is a permutation problem. Yeah, so you should apply a permutation formula. Okay. Okay, how do you calculate this? How many ways can you arrange 4 numbers combination of 4-digit master lock key? Okay, ne hane samo SDS bene. Master lock key ne kan o karak hetan será. Primeiro ne mas ne ya 10 ways. Nomor primeiro ne bele ko ida ne bele kosong bele 1 lo dalai. Primeiro ne o dulas baba mai ma nia ya enene ida nia bele kosong bele 1 bele 2 bele 3 to bele 9. Ida ne mo sanesang, ida ne mo sanesang, ida ne mo sanesang. Lo dalai? So that means every possible, it's just simply 10 and you just simply multiply to each other. 10,000 possible ways. Easy. It's not that hard, no? Okay? So never it depends on the problem. Never but here imi here. Ida nene ita bolnara sa basic principle of basic counting rules. O primero ne, nada? Basic principle of counting rules, yeah? Basic principle of counting rules. If one event occurs in m ways and another event occurs in n ways, and together on all possible ways is just simply m times n ways. Siya ma-lay na ne kariga. Okay. How about this paper, this problem? How many ways can you arrange the word statistics? In how many ways can you arrange the word statistic? The word statistic is constituted of S, T, A, T, I, S, T, I, C, and S. How many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Agora, yan sa nulo, maybe how many ways? Maybe the only difference here is that yan elemento balo ma-repete. For example, S din niya repete. Dala tolo. Sa tama repete na.
T.
T.
She also
T.
repeated 3 times. What
T
else
and
is repeated?
I.
I also repeated 2 times. Agora, tenemos permutation, maybe niya laos na ida be. Ida neo na. N o R na. Nito usa fali da fali na. Formula da segundo ne. Permutation rule neo na. Tamba ita repete. Cada elemento ihan inilarang ne repeated. So in order to calculate this, all you need to do is simply, so you want to know the all possible ways, a number of possible ways is simply, so you have 10 factorial, but then you have the S is what? The S is repeated 3 factorial 3 times for S. And
Three.
I is 2 times. This is for I.
T.
And then that we also have 3 for T. Okay. So now that you have that, then how many ways can you arrange this? So it's just simply 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial over 3 factorial times 2 times 1 times 3 times 2 times 1. Okay, and then you just simply cancel 3 factorial out. So if you count this number in a calculator, you will get about 63,000 different ways. Okay? ¿Tiene comprende todo?
Yes, teacher.
Okay, what
Sir,
about problem?
question.
Yes.
Então, ida impar sini itala sura ida ka?
Good question. That is a good question. Let me just go back to the definition. Okay. If the procedure requirements are satisfied, so there are n items available and some items are identical to others, that some items are available. We select all of the items without replacement. Okay. We consider a range of distinct items to be sequence. If the procedure requirements are satisfied, and if there are n1 alike and n2 alike until nk alike, the number of permutations of all items selected without replacement is this. Okay, so yes, to answer your question, yes. Correct. Laida, either be non-identical will not be. Sekarik niya makala identical. Sekarik niya identical naman. Okay, the rule is this. If they are identical to others and just n1 alike, nema n1 nema o ito ni 3 ne, 3 factorial, n2 alike, that's also the 2, and then nk, and then another n3. Maybe sekarik makalaihe either identical, for example, from the word letter lof o yung itahalo ne, there is no identical, then we will not use this formula anymore. We will use this formula instead. Sekarik niya laihe either identical, ito usa ida ne. And depending on how many words you want to arrange them. I hope this explains your answer, your questions.
Yes, sir.
¿Comprende todo?
Yeah.
Okay, yes. So, rule ida be, ohing ida nene, formula ida nene, ita applicated by here there is an identical. Sekarik ihane maklaihe ida mak identical, antang ita tengki usa fali formula ne. All right. Okay, what about number 10? In a horse racing, a bet on exacta is a race won by correctly selecting the horses that finish first and second. And you must select 132nd running of the contemporary field of 20 horses. If a better, run less 2 of the horse to you be exact. All right, so nidian esa ne. Ibe bang imi panare televisão ema halai kuda be taru ne gale manang osang halai kuda be taru ne. Ia be halai kuda nene game nene waktu manang nene o tengki hili kuda rua. No kuda rua ne tengki juara 1 juara 2 titir malam o menang. Okay, ia evento Kentucky Derby Field nene. Ia kuda 20 kuda mah henaba. Ako sekarik por exemplo, Favanio is a better. Dia makhalo be joga kuda halai taru nene hili kuda rua. Let's say horse 1 and horse 2. Okay, probabilidade sa ida maka Favanio sa menang. okay? And you have up to 20 different horses, right? Favanyo Belehili, what? Belehili, horse 11 and horse 13. I don't know. Or maybe horse 10 and horse 20. We don't know. But iya kuda rua maka same sa juara satu juara dua. It has to be one of the other. So it's still the same thing. So is this a permutation or a combination problem? This is a permutation. Why? Because Bele horse 11 maka juara satu first place. Or horse 30 ma second place. My be, imi bele troca filafali, horse 30 maka juara satu, horse 11 ma juara dua. Senaro ne elemento hanesang, membe event ruane la hanesang ida. Tamirane me idane itakbolane permutation problem. Okay? Since this is a permutation problem, what is the n here? Tene n ini saya. What is n?
N is 20.
N is 20. R is 2.
2. Oh yeah, 2.
Okay, so this is simply probability of 20 and 2 is permutation of 20 and 2 is simply 20 factorial over 20 minus 2 factorial, which is simply 20 factorial over 18 factorial, which is simply equals to 20 times 19 times 18 factorial. 18 factorial, and then you just simply cancel the 18 factorial out. And all you left with is that, which is what? 380 ways. Okay. Double check my math, okay? All right, so that is a bunch of examples that I have given you on the permutation problems. Kene permutation naman na. Any questions? Preguntas, Roma?
None, teacher.
Okay, let's do some examples on combinatorics problem. Okay. Now, in how many ways can you select 3 engineers from a pool of 15 engineers? Por ejemplo, wakara halobe reclutamiento, ema aplica, you have 15 engineers. So engineer 1, engineer 2, up to 15 engineers. Wakara kili, you want to select 3. Wakara recruta ema na intolo. Por ejemplo, Opel recruta engineer 6, engineer 9, or engineer 11. Or you can select first engineer 11, engineer 6, or engineer 9. Agora, eventualmente, hanesan det kala hanesan. Hanesan det.
Yeah.
Composto si Emma nebe hanesan det. Emma ne hanesan det. Meskipun idone kan ola interesen nyo jor 1, jor 2 ba idone, you don't care about it. You just want to select 3 people. So both of these events are just the same. Berarti we counted just as one event. Berarti idone a combinatory problem or a permutation problem. So now it becomes a combinatorics problem. Okay. So A and B, ABC is equal to CBA. This is a combination. So in permutation is not equal. So that's the only difference between permutation and combination. That's a big difference actually. Okay, since this is a combinatorics problem, what is the formula for combinatorics? C and R is equals to what? Did you guys write it down?
N factorial over
factorial
n
over-
minus r n minus r factorial.
Okay. Times R factorial. Okay. So what is our N here? The N here.
15.
Yes. What is our R?
3.
3.
3.
So combinatorics of 15 and 3, you have 15 factorial. And then you have 15 minus 3 factorial and then 3 factorial. So you have 15 factorial over 12 factorial times 3 factorial, which is equals to 15 times 14 times 13 times 12 factorial over 12 factorial times 3 times 2 times 1. Okay, so you just have to cancel this out. And then what you get? Ito ang hira. I get about 455 ways. Okay? Okay, 5. ¿Comprende kalian? Any preguntas? Any questions about this problem? Problem number 11.
None, teacher.
Hey. Find the number of possible 5-card poker hands. Okay, the name is combinatorica, a permutation problem. Por ejemplo, hoy ya as copas, por ejemplo, ya ace of spades, king of clubs. Okay, 7 diamonds, 9 diamonds, or club, spades, club, diamond, and heart. And then jack of hearts. Okay, let's call this, make it a symbol AS, king of clubs, a 7 of diamond, 9 of diamonds, and then jack of hearts. Okay, por ejemplo, niya be 5-card poker hands de mane. Agora niya belemos, idane pertama ne mane kedua ketiga tutir mal mane. Niya mas bele halfali niya J of hearts, 7 of diamonds, 9 of diamonds, okay, king of clubs, or ace of spades. Sila ne composed to isi elemento ne be hanesan de 8. Betul? 90, case, kids of clubs, and space. Scenario diferente kala. Scenario diferente kala.
No.
No difference. It's just the same thing. So we just counted at once. So since both of them are not counted differently, so we just count them all the same. This is a combinatorics problem, okay, not a permutation problem. So our n is equals to what?
5.
5.
No.
5, no?
13,
How many total?
52.
Yes, 52.
52.
And r is equals to 5.
5.
5.
Comprende to? Tama sa naman 52?
Yeah.
Tama kartu ne total ya 52 mahalarang.
Okay.
When you joga kartu ne niya, there's 52 cards in a poker hand, and you want to get 5 different possible 5-card poker hands. So. All right, so this is a combinatorics problem, and you just plug in the formula. C of 52 and then 5 is equals to what? 52 factorial over 52 minus 5 factorial and then 5 factorial. So you have 52 factorial over 47 factorial and 5 factorial. You have 52 times 51 times 50 times 49 times 48 times 47 factorial. You divided that by 47 factorial times 5 times 4 times 3 times 2 times 1. Okay? And then you just simply cancel the 47 out. And then you get about what? If you put a calculator on it, what you get? 2,598,000. 2,598,000 and 960 ways. Okay? Comprende toh? If
Comprendo.
you plug this in a calculator, that's what you get. By the way, does everybody has a calculator? Imo to a calculator kale. Game best.
Yes, teacher.
Huh?
Yes, teacher. I have a calculator.
Okay, sema sila kaya calculator. Excuse me. Sema sila kaya calculator. Apa pero mi ba examen mi thank you calculator ka mi la precisa calculator. Laya telepon ni mana exam la telepon laya nebe. Calculator laya kara agora ba buku sosok kara. All right. Okay, awesome. Good example. How about this one? Let's do another example. What about this one? In how many ways a committee consisting of 5 men and 3 women can be chosen from 9 men and 12 women? This is a bit difficult, huh? Por exemplo, nessa, né? O cara forma comissão ensino superior, por exemplo, o cara comissão a tu be comissão comissão logística, por exemplo. Serviço do governo forma de departamento logística ida. O comissão be hare logística niya. Por exemplo, a comissão niya lara ne o cara que the committee ne you want to have consist of 5 men and 3 women. Ya comissão niya lara ne o cara que mane 5 no feto tolo. Maybe o bele huili husi from available candidate. Available candidate is okay, so the available candidates are available candidates 9 men and 12 women. Okay. And how many ways can you calculate that? Okay. Now, my first question is, so 9 men is, let's say men 1, men 2, to men 9. This is women 1, women 2, to women 12, for example. For example, if you choose men 1, men 9, men 10, men 11, men 12, and women 4, women 6, and women 7. And the second event, you will be selecting M12, M10, M9, M1, and M11. And women will be women 7, women 6, and women 4. Sila consist of all the same element, but just different. Lozalay? Tutirmalo na sana. Lozalay, M1, M12, yeah? Okay, 1, and this is 11. I should put this 11 here. Okay, this is 11. 11 mana. Siro na sandate. Berarti meskipun iha emanang walu ida nene, emanang walu iha ne, emanang walu ida nene, meskipun ini order ne la nesa mebe, sirane consistiu si elemento ne nesa nesa. Jadi sirane lahi diferente da. So that is a combinatorics problem, yeah. So how do you find that? Anybody has any idea how to calculate this? Suggestions? The first thing you need to do is you need to calculate first the selecting men. Let's select first men. So the way you select men is you have how many n? N is 9 because you have a possible of 9 per combination of 9 can be selected from 9. But you want to select only 5 men.
5.
So C of 9 and 5. 9 factorial over 9 minus 5 factorial. 5 factorial. 9 factorial over 4 factorial times 5 factorial. So you have 9 times 8 times 7 times 6 times 5 factorial over 4 times 3 times 2 times 1 times 5 factorial. So I'm just gonna cancel this 5 factorial out. So what you get? So there's 126 ways for selecting men. And then now you go to selecting women. Your N is equals to 12. Your R is equals to 3.
3.
3 is 12 and 3. That's simply 12 factorial. 12 minus 3 factorial. And then 3 factorial. Which is equals to 12 factorial over 9 factorial times 3 factorial. You have 12 times 11 times 10 times 9 factorial over 9 factorial times 3 times 2 times 1. So you just have to cancel 9 factorial. And then you get about 220 ways. So the total number of ways is simply add them up. So 126 plus 220. So you will get about 346 possible ways. Okay. Comprende que le? Questions in this problem?
None, teacher.
All right, yep, hay preguntas, yeah? All right, very good. That means everybody's understand. Okay, what about this problem? There are 10 students in your class, but you can only invite 5 to your birthday party, which is a very mahaloang karakter naman sa ne. Kasi lo karakter, total ya kelas lain sa nulo bakal consider tema na lima po niya pe fiesta be. Será haltinang niya. For example, how many different combinations of friends could you invite? Explain whether to use combination or permutation. And then combination ka permutation.
Combination.
Combination.
Why? Because selecting Mario and Euphrasia, or Euphrasia and Mario is the same, right? So that it's just the same two people, just different order, but it's the same. So order doesn't matter. That's why it's combination. So our N here is, this is a very simple calculation. N is equals to what? 10, and R is equals to 5. So just simply 10 and 5, so 10 factorial over 10 minus 5 factorial, 5 factorial, 10 factorial over 5 factorial times 5 factorial. You have 10 times 9 times 8 times 7 times 6 times 5 factorial, 5 factorial times 5, 4, 3, 2, 1. So, and then you cancels out this one. So what you get? Meta hira. Calculator sir ni. Buti to ba? $252 ways. Okay. Now what about number 15? At the part yeah, I think I'll make this as a homework. I think I've given you enough examples already. All right, ¿qué preguntas, Ruma? Any questions?
None, teacher.
All right, so let's make a quick absences and you can dismiss. So now that you understand already the technique of counting probabilities and such, so it should be easy for you to calculate probability, yeah? So you know a lot about probabilities now. So next meeting, we are going to learn about discrete random variables. And then the next meeting, we're going to learn about continuous random variable, and or we can call it normal probability distributions. And then 7, we are going to learn about, I forget. Probably we can go up to chapter 10 or chapter 20. Not chapter 20, that's too much. Chapter 10 or chapter 15, I hope. If I can get to 15, that would be great. But anyway, let's see what happens. All right, so today is October 22nd in Delhi. All right, Ademia Leite. Alessandra Saldana Silva. Ana Sofia.
Present teacher.
Ana Sofia dos Santos.
Present teacher.
Angelica Fernandez.
Present teacher.
Antonia de Fatima Kaunan. Antonio de Jesus Marsal. Armandino Name. Armandino da Silva Gomez.
Present teacher. Present sir.
Cancio Lopez. Sema present tutti quanti sa semane.
Present teacher.
Cancio.
Silva Gomez ya teacher.
Okay, Gomez Losana. Celso Cardoso. Sedalia Viana.
Present, sir.
Cipriano Bobo. Ediana Saldana.
Present teacher.
Elijah dos Reis Moisés. Efrasia Pereira.
Present, sir.
Evangelita Suarez.
Teacher.
Present, sir.